Lesson 6-4, Day 2, Word Problems. So this first problem says, write and solve a system of equations for this situation. The sum of two numbers is negative 10. Negative 3 times the first number minus the second number equals 2. Find the numbers. Well, to start out, I'm going to define my variables. I'm going to use x for the first number and y for the second number. Those are the two variables that I like using the most. The sum of two numbers is negative 10. The word sum means addition. So if I add together my two numbers, I have to get a sum of negative 10. So x plus y equals negative 10. Negative 3 times the first number. Well, my first number was x, so negative 3 times the first number is negative 3x. Minus the second number, which was y, equals 2. Now my system is ready to solve. You may notice that I have opposites already, so I can add together my system right now, and the letter y, the variable y, is eliminated. So, if I put a 1 in front of my first x, 1x plus negative 3x is negative 2x, and negative 10 plus 2 is negative 8. Divide both sides by negative 2, and x equals 4. So, my first number is 4. And to find my second number, I need to go back to one of my original equations. I'm going to choose the top one. 1x plus y equals negative 10. And substitute 4 for my first number. 1 times 4 is just 4. So 4 plus y equals negative 10. Subtract that 4. And y equals negative 14. So my second number is negative 14. Word problem number 2. Tia and Abby are throwing a party for a friend. Tia invited 5 fewer friends than Abby. Together they invited 47 guests. How many did each girl invite? Well, I will define my variables as T for Tia and A for Abby. So, Tia invited 5 fewer friends than Abby. What that means to me is that the number that Tia invited equals how many Abby invited minus 5. Abby minus 5. So Tia invited 5 fewer than Abby. So if you took Abby's amount of friends and subtracted 5, that would be the same as Tia's. The second equation says together they invited 47. So that means that together, if I added together Tia's plus Abby's friends, together it had to equal 47. So you may notice that this system is not set up for elimination. Right now it is not set up for elimination. It is instead set up for substitution because the first equation says T is equal to, so T is equal to A minus 5. So where I see the other T, I am going to replace it with A minus 5. So A minus 5 plus A equals 47. This is going back to substitution in lesson 6-2. Now, I don't really need the parentheses because there's nothing to distribute. So A plus A, 1A plus 1A is 2A, minus 5 equals 47. So I add 5 on both sides. 2A equals 52. And divide by 2. So Abby invited 26 friends. A equals 26. So I'm going to say Abby invited 26 friends and Tia invited, and then we'll go back and plug in this 26. I'm going to go to the top one because it says Tia equals Abby minus 5. So now if I plug in 26 for Abby, 26 minus 5 is 21. So Tia invited 21 friends. That is our solution. If you wanted to check, you could reread the problem to make sure that it makes sense. Tia invited 5 fewer friends than Abby. 5 fewer, 26 compared to 21, that makes sense. Together they invited 47, so if I add those all together, I get 47. So both of the equations check. Okay, my next situation. The Jones family spent $55.40 on 12 tickets to a 3D show. If adult tickets are $5.95 each and children are $3.95 each, how many adult tickets did they purchase? So I'm going to use A to represent adult tickets. And C to represent child tickets. And what's important in this situation is that you recognize that all of the dollar amounts have to go together in one equation, and the other equation is just talking about how many tickets they bought. So one gets all of the money, the other's just talking about strictly those numbers. So they bought 12 tickets. We don't know how many were adult tickets. We don't know how many were children's tickets. So adult tickets plus children's tickets has to equal 12 tickets in all. Now let's throw the money in there. The adult tickets are $5.95 each, so that means that they would be multiplying how many tickets for adults times $5.95 plus $3.95 for each of the child or children's tickets. So $3.95 times C, and then it has to equal $55.40, the total amount of money that they spent. So now if you take a look at this system, we're supposed to be solving to figure out how many adult tickets. So if we're solving for adult tickets, I want to eliminate the children's tickets. So to do that, I am going to multiply by negative $3.95. So then the result will be negative $3.95A minus $3.95C equals, and now I need to multiply that negative $3.95 by 12. That would be negative $47.40. Okay, so now we can add together our system, and I have eliminated the letter C. 595A plus negative 395A is just 2A. And then 5540 plus negative 4740 is 8. So divide by 2, and I have the number of adult tickets, 4. And that is my solution. I don't have to solve for the number of children's tickets because this question just asked me for the adult tickets. So I'm going to say they purchased 4 adult tickets. A problem like this is one that you have to be really careful on because you're likely to want to solve the entire system and solve for both of the variables. But if this was a question that was multiple choice, where you were given answer choices, you really have to understand that they're only looking for the adult tickets. So if you solve the entire thing, you have to go back to that understanding. Which variable did you choose to stand for the adult tickets? Okay, now you're ready to work on your homework. We did not have a summary today because we did not have a new essential question. Please make sure that you set up your systems and solve, and make sure that you go back to see if your answers make sense.